This video is for Unit 2.2 on phylogenetics. First thing you need to know about phylogenetics is what is phylogenetics. So far in class we've been talking about something called hierarchical classification, and that's the classification system of using domains, kingdoms, classes, families, so forth and so on to show relatedness between organisms. Cladistics or phylogenetic systematics are another way to classify organisms. But this time, instead of classifying them by their anatomical similarity into kingdoms and domains and so forth, instead we're going to classify them based on the ancestors that they have in common. And the way we're going to do that is by putting them into clades or clades. Okay, clades are groups of organisms that have some anatomical similarity. And we're going to use that word quite a bit, so I wanted to introduce it here. But as I go through the examples, I think it'll make a little bit more sense rather than just using that definition. So the example I'm going to start with is that of a cow and a sea star and show how they are related ancestrally. The question you want to ask is, what are other organisms that are similar to cows and sea stars by an anatomical structure? So the structure that we're choosing, or the characteristic we're choosing, is all animals that produce eggs, because both cows and sea stars produce eggs. So we can put them in a clade. So this is a clade, a group of organisms that share the same anatomical similarity with some other organisms. So we've got the sea star, the cow, emus, which are big flightless birds, kind of like ostriches, salamanders, and the blue whale all produce eggs. So that's the first clade. Then we want to break it down into a smaller clade that excludes one of these organisms. So it's going to be another anatomical characterization. In this case, we're going to take 4 opposite appendages as our next clade. So that clade leaves out the sea stars, because sea stars do not have 4 opposite appendages. They have many arms in many cases, and they're not opposite each other. But salamanders, cows, emus, and whales do have 4 opposite appendages. They have whales have flippers that are opposite of each other. Emus have wings and legs that are opposite each other, and cows and salamanders have legs that are opposite each other. So now they're in a second clade. So clade 1, again, was all the organisms that had eggs. Clade 2 is those organisms that have 4 opposite appendages. In the next clade, again, we're going to exclude one organism. We're going to choose our anatomical characteristic is a 4-chambered heart. Emus, cows, and whales all have a heart with 4 chambers, 2 atria and 2 ventricles. A salamander does not. So it has now been excluded from that new clade, but it's still a part of the original clade, produces eggs. Now we're using a placental mammal as our clade characteristic. So these are mammals that carry the young inside of their bodies and give birth to a fully developed baby. That would be cows and whales. Emus do not belong to this clade because they lay eggs, so they are not placental mammals. Again, salamanders are still out of the clade, and sea stars are still out of the clade. So the placental mammal clade only has 2 organisms. Final division is going to be appendages with flippers. So that's our blue whale. So the blue whale is the only one that has all of these clades, or belongs to all of these clades. It produces eggs. It has 4 opposite appendages. It has a 4-chambered heart. It is a placental mammal, and it has appendages that are flippers. If we look at the emu, we can see it is not in the yellow clade with a placental mammal or the tan clade with appendages or flippers, but it is in the clade for a 4-chambered heart, 4 opposite appendage, and produces eggs. Okay, that's how the clade breakdown works. And now we're going to use that information to figure out ancestry, or how those traits were passed on over time. So we arranged those organisms and their traits into something called a cladogram. Remember, the study that we talked about in the beginning was cladistics. So cladogram is related to cladistics. You take your information or your cladistics and you put them into this chart. So first thing I want to point out is on this chart, time is moving forward as we go from bottom up. Down here at the bottom is the past, And up here at the top is the present. Sorry about all that noise. That's my cat banging on the door. I'm going to get that real quick. Okay, so past at the bottom, present at the top. So as we go up our diagram, we're getting closer to characteristics in the present. In other words, the characteristics that a lot of the organisms share are older characteristics. For example, producing eggs is an older characteristic than placental mammal because not as many organisms have that characteristic. You can see placental mammal is higher up from the base than producing eggs is. So that's how we keep track of the time. So time is not traveling this way. Okay, that would be an incorrect representation. We are not saying that sea stars are older in the geologic record than cows, or that sea stars have been on the planet longer than cows. That's not what this cladogram is showing. Okay, it's simply showing the characteristics of those organisms and the timeline for the development of those characteristics. So at this point in time right here for producing eggs, okay, that is an older time period. The sea star has eggs because the sea star starts right here. Eggs happened before the sea star, so the sea star did have eggs. But after the sea star branched off, here's the sea star branch, then we have 4 opposite appendages. So the sea star does not have 4 opposite appendages, but everything on up does. Just like everything on up also produces eggs. The salamander has 4 opposite appendages, but since it branched off right here, it does not have a 4-chambered heart. But everything on up does have a 4-chambered heart. So emus, cows, and whales. The emu branches off right here, so it does not have a placenta. Okay. But the cow, which branches off here, does have a placenta, and again, everything before it, right? The cow has a placenta, 4-chambered heart, 4 opposite appendages, and does produce eggs. And then the whale, being here at the top of the cladogram, has all the characteristics that come before it. So when you're reading a cladogram to find characteristics, you always back up behind and see what does that organism have before it branched off the line. Let's do an example of an emu. Emu is right here. What characteristics does it have before? Had a 4-chamber heart, 4 opposite appendages, and produces eggs. So those are the characteristics of emu. Anything that comes after the emu is not a part of the emu. So it is not a placental mammal, and it does not have appendages that are flippers. So that's how you read a cladogram. It also, remember, shows relatedness. A sea star is more closely related to a salamander, because they are close together on the cladogram, than it is to a whale, because they are far apart on the cladogram. So a lot of information can be gained from this type of diagram. All right, here is a basic background of information on a variety of organisms. We've got a kangaroo, lamprey, which has got kind of a fish-like thing, a rhesus monkey, a bullfrog, a human, a snapping turtle, and a tuna. And down the left-hand side here, we've got all of these different characteristics, these anatomical characteristics that they may or may not have. So for example, a kangaroo is a chordate. In other words, it has this notochord thing when it's developing that's kind of like a spinal cord. Has a vertebral column, a backbone, has paired legs, has a 4-chambered heart, has mammary glands. It is not a placental mammal, and it does not have short canine teeth. So it belongs to 1, 2, 3, 4, 5 clades. And that's what's shown down here for number of total traits. Okay, it belongs to 5 clades. Whereas the lamprey only has one of those traits, so it only belongs to 1 clade. So what I would like you to do is, taking this information in your notebook, I want you to draw a diagram similar to the one that I did, that Venn diagram with all those nested boxes. Remember, so we started here, write the trait, write the organisms that have that trait, write another box, write the trait, write the organisms that have the trait. So you're making those nested diagrams in your notebook for each of our clades that we have. And then from there, draw the cladogram, right? That's this diagram like this, showing what order those organisms are lined up in, and therefore what order the traits show up on that bottom line. So give it a shot, give it your best bet or the best shot on your own. In class, we'll talk about them and share our results, and you can confer with other people. But I want you to give it a try and see if you can't use that diagram again to go back and create these two things. So you may have to rewind this a little bit, pause it, and get all your traits so that you can make your Venn diagram here first. This will take the place of filling out a form for the video, so don't worry about doing that part. Just finish the Venn diagram and the cladogram in your notebook.